So we are talking about the JWST Science Use Cases now. And this is sort of historical because these use cases have been developed many years ago by some scientists at STSCI. And then the JDAT team, the JWST Data Analysis Tools team, took them and tried to put the science use case into a workflow into Jupyter Notebooks. And this had two aim. It aimed at showcase the workflow and show what JWST can do, show also what the platforms can, what the libraries and AstroPy packages and the visualization tools can do, but also to inform us and the developers of what functionality is still needed. So why all that? JWST is a complicated machine, and it needs tailored tools to visualize and analyze the data. If you have written a proposal or thought about writing a proposal, you know more or less what the workflow is. You'll get an idea, you go to JDocs, you look at all the modes and possible observations, and you decide what you need for your idea. Then you can go to the exposure time calculator and the astronomer proposal tool, where you can craft your observations, you write the science of the proposal, then JWST flies, you get the raw data, and they are run automatically through the JWST calibration pipeline, but you can also rerun that. But after that, you get your data from just data points to science, you need some analysis tools. And this is where we come in and where we use this science use case to develop the JWST data analysis tools. So this is a page, if you download the presentation, the title is a link that will take you to exactly this page. So this is a page on JDocs. If you haven't looked at JDocs recently, you'll see now it's different and it has been revamped. So on this page, you'll find different example science programs for all the instruments and also for multi-instrument. So this is the first resource that I want you to look at in your own time. Then we have another page that is the notebooks page. Again, that title is a link. And these are all the notebooks that the JDAT team has developed and put out for the community. And there are 22 notebooks in total, spanning different science use cases and different techniques, different data sets. So there is a lot in there that you can explore. So in the next few slides, I'll show you the workflow, how these notebooks can be used. So these are version controlled. So they live on GitHub. The data files live on a cloud, so they can be downloaded directly through the notebook. You don't have to go somewhere else and get your data to be able to use the notebook. So these notebooks come with their own data. And together with the Jupyter Notebook and the data files, you get the requirement file. That is a list of all the packages that you need to work with these notebooks, with each of the notebooks. So how do we do that? We open a bash terminal and we clone the repository. So we copy everything that is on the GitHub repository on the laptop. Today we'll work on the platform, so you don't have to worry about doing it on your own laptop. So it's a practice. Consider it a practice session. So you download the whole thing, then you can CD into the appropriate folder of the notebook you want to work with. And then you see in your folder, in that folder, you'll find the requirement file and the Jupyter Notebook. So you create first an environment, and then you can install all the packages. Keep in mind that in the future, we're working to get these more streamlined so that if you want to work with a specific notebook, you just run a command and it will do the whole thing. But for now, it's Git and Conda and pip. So then you'll have your Python environment ready. You can open your notebook, get the data from Box via links that are in the notebook, and then you can do some science and explore these use cases. This is another page that I'll show you later how to get to this page. but it's the list of the notebooks, the same notebooks that are linked on the JDocs page, but they're rendered here. So it's not just the code, they have been fully run and rendered, so you can see also the outputs there. And this is a page that you reach either via, I think we have a link on JDocs, but it's also from the GitHub page. I mean, it is from the GitHub page. So today we will propose you to work with one of five notebooks or whatever you have time to work with in these 2 hours. But we propose you 5 notebooks. The first one, the authors are Ori Fox and Tracy Beck. It's an IFU analysis about a cube from Gemini, and it's the analysis of a iron feature in this cube. So you'll use some specutils, AstroPy, but also one of the visualization tools, CubeViz. The second notebook, which is a set of 4 notebooks actually, the second use case we propose you is the optimal extraction and analysis of Grissom spectra with nearest simulated data of spectra, galaxies in a galaxy clusters, so spectra from a galaxy cluster. The tools you can use for this one is, the tool you can use is specutils. And the cross instrument could be NearSpec because you could do the same workflow for NearSpec observations. The author of this one is Takahiro Morishita. The authors are on call today, so you can reach them on Slack if you have questions. But I believe Ori and David, we'll see him later for another notebook, actually the next one, are online. So you can also reach them directly here. Here is David Singh's notebook, is about transiting exoplanets with NearSpec bots. So there is a simulated data set for NearSpec bots, and the tools used are AstroPy and SciPy mainly. The fourth is Harry Ferguson is the owner of this notebook and is the estimate of sky background in complex scenes. So this doesn't come with a data set because during the notebook you basically build the data set, build a very pathological background and try to remove it from the image using photutils. And the last notebook we propose you is another cube, IFU cube notebook. The authors are Beth Sargent and Ori Fox, and it's it's a MIRI MRS simulation of an M star, and you want to extract spatial spectral features from the cube using specutils, spectral cube, and photutils, but also using CubeViz again, so the visualization tool. So to get started, we'll need to run these few commands on the platform. I'm not going through them now because I'll show you, I'll do it with you in a moment, and I'll also copy these commands in Slack so you have them handy to copy and paste. And in this page, and this text will also be copied in Slack, is the name of the folders of the 5 notebooks that I just presented you. So what we can do now is we can pick a notebook and do the workflow together, or you can pick your own, the notebook you prefer, and do the workflow together with me, but for your specific notebook. And then you can work on the notebook. There are breakout rooms here, so you can go to the breakout room of the specific notebook and work with other people who are working on the same notebook. And you can help each other, but we're also here to help you, both the dev team and the owners of this notebook. And because we love your feedback and contributions, these slides, I'm just showing you that you can contribute your own notebooks if you want. So if you have a nice workflow you want to share with us and with the community, you can contribute a JDAT notebook. And if you download the slides, you'll have a link where everything gets started. Is a read the docs. So there is instruction on how to work out a notebook and contribute it. And while if you want to use the notebooks that are already existing, you can, and you find issues, you can let us know through the help desk, or you can file an issue directly on GitHub if you're familiar with the GitHub workflow.